Good morning, my dear students. So, in this PPT, I'm going to tell you about the concept of plane stress and plane strain, and what are the relationship between stress strain relationship between both the case. Okay, so normally plane stress is nothing but what? So, plane stress is represented by a very thin plane. Okay, thin plate. Okay, so in XY direction, plane subjected to in load, that is a in plane load. Okay, along the X or maybe Y. Okay, direction, and no load along the normal to the plane. Okay, such type of the problem we are going to call as plane stress problem. Okay, so, let me understand in detail now. Okay, so what do you mean by plane stress here? So it is defined as the state of a stress in which the normal stress, okay, that is a sigma, and the normal stress is denoted by sigma, and the shear stress t tau, okay, directed perpendicular to the plane are assumed to be 0. Okay, such type of conditions is, we know means we are going to call as what? Plane stress problem. Okay, that is sigma z is equal to tau, that is shear stress tau yz, which is equal to our the tau zx, which is equal to 0. Okay, so this condition is satisfied means we are going to call as plane stress problem. Okay, so what do you mean by plane stress problem? Okay, no load along the normal to the plane, that is a z direction. No load should be acting on the z direction. Okay, so such type of element we are going to call as what? Plane stress. Okay, so otherwise on another definition we are going to call as what? If the body has a dimension along the normal direction, okay, z direction, okay, or the thick loading applied in this direction, then the problem is going to call as plane stress problem. Okay, so these are some of the example for the plane stress. Okay, a ring force fitted onto a shaft. Okay, that is a thin plate with a hole, a thin cantilever plate. Okay, thin plate subject to a force in their plane only, that is sigma z is equal to tau xz and tau yz, which is equal to 0. Okay, so just to understand this plane stress, nothing but what? There is no force, there is no load is acting in the third direction. Okay, there will be third direction will be absent, that is stresses will become 0. Such type of condition we are going to call as what? Plane stress. Okay, so these are some assumptions we are going to consider in the problem. Okay, in the plane stress case. Okay, so what is the first? All the loads applied to the plate act in the mid plane direction and are symmetric with respect to the mid plane. Okay, so all the forces should be acting, both the plane should be symmetric. Okay, so second one is all the support conditions are symmetric about the mid plane. Okay, so both the forces should be same while considering in the middle plane. Okay, so in the plane the displacement, strain, stress can be taken to the uniform through the thickness. All the forces should be act through uniform only. Okay, and the fourth one is the normal and shear stresses component in the z directions are going to be considered as negligible or 0. Okay, so these are some of the assumptions we are going to call as what? Plane stress. Okay, so next one is, this is very important. Okay, so in examination they may ask you write the stress strain relationship for the plane stress, means you have to write these three conditions. Okay, so actually we have to derive this equation, but for your syllabus you have to write the direct. Okay, so how this equation comes, we have derivation will be there. Okay, so according to derivation you will get this final equation, but your syllabus you have to put direct equations. Okay, so first equilibrium equation. So here there will be a in the two directions stresses will be acting, that is sigma x and sigma y. Okay, that is f of x and f of y. Okay, so equilibrium equations we are going to call as two terms, that is dou sigma x by dou x plus dou shear stress xy divided by dou y plus f of x, which is equal to 0. Okay, so this is the force along x direction. Okay, and the second equilibrium is equal to along the y direction is equal to dou by tau of xy dou x plus dou sigma y by dou y plus f of y, which is equal to 0. So this is what the equilibrium equation we are going to call as. Okay, and the second one is a strain displacement relation. Okay, so this is also very important, strain displacement relation. Okay, so here strain displacement relation is equal to what? Again there will be a two, okay, there will be a two strain, okay, x and y. Okay, so strain along x direction is equal to dou u by dou x, and strain along y direction is equal to dou v by dou y, and combination of these two, that is what? Shear stress xy. Okay, gamma xy is equal to dou v by dou x plus dou v by dou y. Okay, these are the strain displacement relationship for plane stress problem. Okay, coming to the stress strain relationship, this is most important. Okay, as the name indicates, stress. Okay, so stress nothing but there will be two direction stresses will be exist. Okay, that is the sigma xx, that is the stress along x direction, stress along y direction, and in between these two plane a shear stress will exist, that is shear stress tau xy. Okay, so which is equal to capital E by 1 minus gamma square, that is E stands for what? The modulus of, that is what? The material property, Young modulus. Okay, 1 minus gamma square. Okay, so this is the matrix we are going to get after deriving the equations, that is 1 gamma 0 gamma 1 0 0 0 1 minus gamma by 2. Okay, matrix close, and here the strain along the x direction, strain along y direction, and shear stress x of gamma xy. Okay, so this is a condition for plane stress, what? The plane stress strain relationship for plane stress problem. Okay, so these equations are very important for the point of examination. Okay, Coming to the plane strain, okay, so plane strain definition is similar to the plane stress, okay, but in this, as the name indicates, strain. Okay, here look at the strain means the z direction along the, if you consider any plane, okay, any long object, that is a long string, in that there is a third direction strain will become 0. Such type of element, okay, that condition satisfied means you are going to call as plane strain. Okay, so definition says, so it is defined as the state of a stress in which the normal strain, that is epsilon, that is the strain, and the shear strain tau to the xy plane are assumed to be 0. Okay, that is the condition is what, strain along the z direction which is equal to gamma xz and gamma vz which is equal to 0. Okay, so if this condition is satisfied means we are going to call as plane strain problem. Okay, so now if you define another way definition, it means if the body has a dimension along the longitudinal is very long, okay, that is a length, and the loading subjected to the perpendicular to the longitudinal axis, okay, longitudinal axis perpendicular to the longitudinal axis, such type of problem you are going to call as plane strain problem. Okay, so consider a long strip element. Okay, here the loads are acting uniformly to the that. Okay, so here look at the condition here, loading subjected to perpendicular to the longitudinal axis, all the loads are acting which is subjected to the longitudinal axis only. Okay, such type of problems we are going to call as plane strain problem. Okay, so these are the examples. Okay, that is pipes, long string footing, retaining the walls, gravity dam, tunnels, a thick cylinder subject to a internal fluid pressure. Okay, so here I consider the example for a thick cylinder subject to a internal fluid pressure. Okay, so this is about the plane strain. Okay, so these are some assumptions we are going to consider in the plane strain problem. Okay, the length of the structure is very large in comparison with the other two dimension. Okay, so look at here, the length should be larger as compared to other two dimension. Okay, so the load is applied only the normal to the longitudinal axis. The loads are uniformly distributed along the length of the body. All the loads should be act uniformly, and that should be applied to the what, longitudinal axis only. Okay, and the third one is the support conditions are the same along the z axis. Okay, these are the three assumptions we are going to consider in the while solving the problems of plane strain. Okay, so coming to the similar condition to the last one, that is what the same, it is similar to that plane stress equations. Okay, again here we can define the governor equation in terms of three, that is equilibrium equation, a strain displacement relation, and a stress strain relation. Okay, so this slide is very important for the both. Okay, so along here also there will be two direction, sigma x and sigma y, and f of x and f of y. Okay, so these two equations are called as equilibrium equation, that is dou by sigma x by dou x plus dou shear stress xy by dou y plus f of x is equal to 0, and dou tau shear stress xy whole divided by dou x plus dou sigma y plus dou y plus f of y is equal to 0. Okay, so this is what these two equations are we are going to call as the equilibrium equation. F of x nothing but what, the force acting along x direction, the force acting along y direction. Okay, so coming to the next equation, that is the strain displacement relation. Again here there will be two strain will be exist, one is along x direction, one more is along y direction. Okay, so strain along x direction which is equal to what, dou u by dou x, and strain along y is equal to dou v by dou y. Okay, we are going to consider here displacement as along x is u and displacement along y is v. Okay, so combination of these two we are going to call as the shear stress, that is gamma xy which is equal to dou v by dou x plus dou u by dou y. Okay, so this is about the strain displacement relation. This is very important. Okay, define sometime they may ask you, so define plane strain and write the strain displacement relation, means you have to write these three. Okay, so coming to the last equation, that is a strain relationship. Okay, that is a stress strain relationship. Okay, again here there will be two direction stresses will be acting, that is sigma x and sigma y. Okay, so that is sigma x stress along x direction, stress along y direction. Okay, and shear stress that is xy. Okay, so which is equal to E, that is a material property or Young modulus, E is equal to 1 plus gamma 1 minus 2 gamma. Okay, so in the matrix of 1 minus gamma, gamma 0, gamma 1 minus gamma 0, 0 0 1 minus 2 gamma whole divided by 2. Okay, so this is the matrix we are going to consider in the stress strain relationship. Okay, and here coming to the final, that is the last, the strain along x direction, strain along y direction, and shear stress along xy direction. Okay, these two conditions, that is a strain displacement relation and the stress displacement relations, are very important for this conditions. Okay, so you have to write these two equations. Okay, actually you have to derive these equations, but for your syllabus what they have to write the direct equations. Okay, so look at this diagram. Okay, what is the difference between the plane stress and plane strain? This is most important slide. If you understand this, means you can write anything. Okay, So coming to the first the plane stress. Okay, so this is applicable to the bodies whose dimension is very small in one of the coordinate dimension, that is a thin plane loaded in the thin plate. Okay, so here look at this, applicable to the those bodies which is having very small dimension, okay, in one coordinate. Okay, while coming to the plane strain, applicable to the body that they are very long, on whose geometrical and loading are not varying significantly in the loading conditions. Okay, for best example for this is what, the long strip, that is a long cylinder, but here a ring fitted with the a shaft. Okay, so those are the example for plane stress and plane strain. Coming to the condition, so here again in the third direction, sigma z is equal to 0. Here the strain along the third direction, that is sigma z is equal to 0. Okay, so look at here, the if you look at this diagram, so plate with a hole. Okay, so here very small dimensions are present in that. Okay, but here a long, we are going to consider a long pipe. Okay, and this is about the damp due to a horizontal loading, so all are uniformly distributed load present in this diagram. Okay, so coming to the fourth, that is condition, that is a strain along the z direction is not equal to 0, but here stresses will not equal to 0 in the third direction. Okay, so what are the example? So in plane loading of a thin plate or ring press fitted on the shaft. Okay, analysis of the damped cylinder. Okay, retaining walls is some of the example for plane strain. Okay, this is same, that is a write the plane stress strain relationship means you have to write. Okay, how you are going to, why you are going to call as stress means, here the stress, this is the strain, this is stress, this is the strain, so that's hence we are going to call as stress strain relationship for this plane stress problem. Okay, so this is very important. Okay, so this is for the third dimensional object will be there, stress strain. Okay, we have to derive this equation, we have to derive that time I am going to tell you this equation. Okay, so just you have to remember for 3D diagram, 3 into this is a 6 into 6 matrix. Okay, we will derive this equation, so no problem. Okay, stress strain relationship for 3D elastic body. Okay, so this is about what the concept of plane stress and plane strain problem. Okay, so you have to here what you want to do here, it means we have to write the stress strain relationship for both the plane, that is plane stress and plane strain. You have to buy it or whatever you want to do it, that you have to remember that equations. Okay, so that equations are very important for solving the problems. Okay, so just to remember from this slide, plane stress nothing but what, the third direction stresses will become 0, and plane strain nothing but what, the strain along the z direction will become 0. Okay, and we have to remember the equations. Okay, that is most important in the plane stress and plane strain problem. Okay, so in the this third condition we will derive equation, that is the last slide. Okay, well, if you derive that equation means you will understand that. Okay, so I hope you understand this plane stress and plane strain concept. Okay, okay, thank you.